Hello students. So today we are doing physics Cambridge IGCSE paper 2. This is zeros. As you can see the code, it's 0625 paper 1 2 Feb March 2023. It's a multiple choice paper 1 core paper. So it will have 40 questions of multiple choice. Okay, so let's start with the first one. A measuring cylinder contains water. The diagram shows the measuring cylinder before and after some of the water is poured into a beaker. So, okay, see, we know that the difference between these two, the difference between these two will give you the how much water has been poured into the beaker. So, first of all, we have to calculate this thing. Okay. Now, see, the first thing that we have to do, we have to measure how how much this one count measure. So, this one division. So, how many divisions are there? One, two, three, four, five. Five divisions. So, this is 25. So, 25 by 5, that means one division means 5. So this is 100, this is on 1 2 3. Third division, so this is the reading of this will be 100 plus 3 into 5, that is 15. So this is 115. And when the water has been poured, the amount of this is, see, this how many divisions are there? 1 2. So this is 50 plus 2 into 5, so which is 10. 50 plus 10, that is 60. Now the difference between these two, 115 minus 60, that is 55 centimeter cube. So the answer for this is how much water has been poured into the beaker. C is the correct one. Okay, now the next question. The diagram shows the speed time graph of a car. Okay, this is a speed time graph, and you know, x this is actually the slope, and you should know that the slope of the speed time graph that gives you the acceleration, or you can also say, you can also call this as this portion is changing velocity. You know, because you know what's an acceleration is, in which the velocity is increasing, or you can say changing velocity, whereas this part represents a constant velocity if the line is parallel to the x-axis. Now, which row describes the motion of the car at the point x and at the point y? Okay, we know that x is basically moving with changing speed, and this is moving with constant speed, because this line represents that the object is moving with constant speed. So D will be the correct option. Okay, third one. A ball is dropped in a vacuum from a height of 4 meters above the surface of Mars. Okay, so they are at Mars. The acceleration of the acceleration of the ball at a height of 2 meter is 3.8 meter per second square. Okay, now what is the acceleration of the ball at a height of 1 meter above the surface of Mars? Now see, when you are like, you know, surface of Mars, so the acceleration due to gravity, that acceleration due to gravity, which is 3.8 meter per second square, that will remain constant. That will remain constant at every height. Okay, so what is the acceleration of the ball at a height of 1 meter above? That will be 3.8 only. It is not going to change whether it's a height of 4 meter, 2 meter, or 1 meter, or anything like 100 meters. It is not going to change. That remains constant. So third B is correct. Fourth one. Two objects are placed on a balance, one on each side as shown. Okay. Now, which property of the objects can be compared using the balance? Now, see, this balance, see, weight, mass, and volume A part. No, we cannot measure the volume. You cannot measure volume from this. Weight and mass only, I think B is the correct option, because either you can measure weight or mass. Again, volume and density, no, because we cannot measure density only, no. So B is the correct one. Fifth, a rectangular swimming pool is 50-meter wide, 50-meter long, 25-meter wide. It contains water at a depth of 2 meters. Okay. The density of water is 1000 kilogram per meter cube. What is the mass of the water in the pool? Okay. So see, we know that mass is volume into density. So now how to calculate the volume? See, this is a rectangular. Basically, it makes a cuboid. So to calculate volume, this will be L into B into H. So that is 50 into 25 into 2. So this is 2500 meter cube. So volume is 2500 meter cube and density they have given 1000 kilogram per meter cube. So what will be the mass? Mass is volume into density. Volume is sorry for this. Volume is actually volume is actually 2500 meter cube. And what's the density? Density they have given 1000 kilogram per meter cube. So this and this will get cancelled. So you will get 2500,000 kg. So D is the correct option. And students, if you like the video, please do like, share and subscribe, because your subscription is really very important for me. Because of your subscription, I get inspiration to create more such videos like it. So let's continue with the paper. Now question 6. An object is rising vertically at a constant speed through water. Now see, is rising at a constant speed. There are three vertical forces acting on it. The weight W is always acts in downward direction, the drag force D and the upward force U. Okay. Which diagram shows the magnitude and the direction of vertical force acting on the object? Now see, this object is underwater. So first of all, weight always acts downward, that's fine. But you know, when it is moving upward because of the upward force, remember the drag force D, this drag force D will always act in the opposite direction. That means if it is moving up, the drag force will move will act in the downward direction. So these two diagrams, so our answer is between these two. Now the point to be noted is that it's moving with a constant speed. Now constant speed means the total force, like the total upward force and the total downward force, that should be zero. That means the resultant force should be zero. So uh, if you see in this is 2 and this is 3 plus 1 4. So this is not, and you see this is 3, upward force is 3 and the downward force 2 plus 1 3. So this is equal because it is moving with constant velocity and the total upward force should be equal to the total downward force. So option D is the correct one. Okay. 7. Which force produces heating during the contact with a moving object? So see, we all know that it's actually because of the friction. Similarly, like when we rub our hands get heated up. That's because of the friction. So it is the frictional force, uh, because of which it is a frictional force which produces heating during the contact. Okay. Next one. A meter rule is balanced at its midpoint. Okay. So let's make a meter rule. This is a meter rule. We all know that this starts from 0 and this is 100, and let this be the balance point over this is balance. Let this be 50 because it's balanced at the midpoint. Okay. It remains balanced when a 3 Newton load is hung from a 40 centimeter mark. So let this be 40 centimeter and the load is 3 Newton is hung. Okay. And the second load is hung from a 80 centimeter mark. So let this be 80 centimeter. Okay. And this load, take this as W. What is the weight of the second load? Now as we can see that this is still balanced. That means the total clockwise movement. See, clockwise movement is like this. Clockwise movement will be like this. Now this is because of this, it's causing a clockwise movement. So let's calculate this. The distance from the middle point is basically 30. 80 minus 50 is 30 into W, the weight. This should be equals to, now this is producing, this tends to move in this direction. So this is the anti-clockwise movement. The total anti-clockwise movement is equals to the total clockwise movement. So this will be 10 into 3. So this is 30 and this is 30 into W. 30 cancel, W equals 1. So A is the correct option. Okay, ninth one. A student measures the length of a spring. Okay. She then attaches different weights to the spring. Okay. She measures the length of the spring for each weight. Okay, she is measuring the length of the spring for each weight. The table shows our result. Now see, weight 0 means this is 520 mm. That means it's the natural length of the spring. What is the extension of the spring when a weight of 3 Newton is attached to it? Now, when you are attaching 3 Newton to it, the total length is 533 millimeter. So, what's the extension? Extension will be this, the extended length minus the original length 520. So, this is equals to 13 millimeter. So, answer D is the correct option. 10th. Which power station produces the greatest atmospheric pollution for each unit of energy generated? Yeah, we know that it's basically a gas fired power station only, because lots of amount of that fuel, whether in the form of a gas or in the form of any like ethanol or petrol, they are burning. Not petrol, actually they burn coal in the fire gas power station. So it is a fire gas power station which produces the most pollution. For 10th, option A is correct. Okay, 11th. A 500 Newton weight is raised to a height of 5 centimeter. Okay, how much work is done by the force? Work is done. See, the work done is basically, the total amount of energy that it has attained because of the height. So that is given by mgh. It's actually the potential energy, means the total potential energy gained by the object, or gained by this 500 Newton weight, is the work done by the object. So this is what? This is mass. Actually, mass into g. Mg is actually the weight. So the value of mg will be 500, and it is raised through a height of 5 centimeter. Now see, 5 centimeter, you have to convert this 5 centimeter to meter. So this will be into 5 by 100. Cancel these two zeros. This is 25 joules. The amount of work done will be the A part, 25 joules. 12th, what is the unit of power? We know that power is work done upon time. Basically, unit is what? What is the option D? What is the joules per second? Okay. 13th. The diagram shows a rectangular block of weight 16 Newton. Oh, okay. The weight of this is 16 Newton. It is resting on a flat surface. Like as you can see, the flat surface that is resting is this. Resting on a flat surface. What is the pressure at the base of the block due to this weight? Now we have to calculate the pressure. See, what is pressure? Pressure is force upon area. We know. What is the force? The force is because of its weight only, which is 16 Newton. 16. And what's the area? See, it is resting on this platform. Basically this. So the area is 4 times 5. 4 times 5, that is equals to 20 centimeters square. And we have to give our answer in Newton per centimeter square only. So if you do 16 by 20, that comes out to be 0.8 Newton per centimeter square. So 0.8 C. So you can see 13th C is the correct one. Okay, now let's come to the next one, 14th. A piston traps a mass of a gas inside a cylinder. Initially, the piston is halfway along the length of the cylinder. Okay, the piston is now moved towards the open end of the cylinder. Okay, now it is basically expanding, increasing the volume. The temperature of the gas remains constant. Okay, the temperature is constant. How are the density and pressure of the gas affected by moving the piston? Now see, as you are increasing the volume, so when you are increasing the volume, it's obvious that the density will decrease, because see, what is density? Density is mass by volume. Now mass remains the same. Now see, in this case, from here to here, you are increasing this volume. So if you consider this as a fraction, when you are increasing the volume, the density will go down. The density will decrease. Okay. Pressure. Now see, what is pressure? Pressure is basically when the gas molecules, they collide with the walls of container. When these gas molecules are colliding with the walls of container, they transfer their momentum. Okay, So that's how the gas exerts pressure. Now when you increases the volume, okay, now what has happened? The total, this volume has been increased, but the molecules remain the same. So the number of collision will decrease. Hence the pressure will also decrease. So both density and pressure will be decreased. So this is decrease. A is the correct one. Okay. 15th. Which statement describes what happens to the air particles when the air is heated? We know that when the air particles are heated, they gain extra energy. They gain extra energy, or you can say their kinetic energy is increased. They start moving rapidly. So B is the correct one. The particle moves more quickly. Okay. Now see, you can see the D part. The particle vibrate faster. Actually, this is for the solid particles, not for the gases, because we are talking about the air. So B is the correct option. The particle moves more quickly. Okay. What happens when the temperature of liquid increases? Now see, when the temperature of the liquid increases, the molecules starts moving with more speed, and as a result, what happens? As a result, the spacing between the molecules will increase. Okay, hence what will happen? The volume will decrease. So you know that density is mass, no sorry, volume will increase. Density is mass by volume. So when the spacing is increasing, that means volume is increasing. So that means if you consider this as a fraction, when this part is increasing, the fraction is decreasing. That means the density is decreasing. So hence C, you see that the volume of liquid increases. Why? Because spacing between the molecule increases, they move more faster, and making the liquid less dense, the density will decrease. Okay, now the next one. In which state of matter can thermal energy be transferred by convection? Okay, convection is basically when there is actual movement of particles. So in actually, in gases and liquids, this B part is correct, because in gases and liquids, the molecules, they can go like throughout the body, they can move throughout the body. So if you consider this as a beaker and you are heating it from the bottom, if you are heating it, then how this liquid gets heated up? That's because the hot the hotter particles, the molecule the hot molecule will rise up and the colder molecule will take its place. So this what is the phenomenon of convection. So this can only take place in gases and liquids because their molecules are totally free to move inside that whole liquid or a gas. Okay. 18th. The transverse base moves along a rope. The diagram shows the position of the rope at one particular time. Okay, now this is a transfer wave. Now, which two label points are one wavelength apart? So first of all, see what is one wave. Now, if we consider a point X, now see this is the one wave. This makes a complete wave, and the distance moved by that one wave is known as the wavelength. So this X and Y, this point actually the X was given. So this X and Y, sorry, X and Z, this part, X and Z, they are one complete wave. So what is wavelength? The distance covered by a complete wave, because see from here to here is a complete wave, and this is the distance. This is the distance moved by this complete wave, which is xz. Okay. 19th. The diagram shows the ray of light being reflected from a plane mirror. Yeah. So this is a plane mirror. You can see this is normal. This is the incident ray, and this is the reflected ray. Which row identifies the angle of incidence and reflection? See, angle of incidence is basically the angle between the incident ray and the normal, which is x, and angle of reflection is the angle between the reflected ray and the normal, which is y. So x comma y, which is c. So for 19th, c is the correct option. Okay. 20th. Blue light has a typical wavelength of 5 × 10⁻⁷ meter. Okay, they have given for the blue light. and a frequency of 0.6 into 10 to the power 15 hertz. Okay, they have given you the wavelength and the frequency. Which rows gives a typical wavelength of frequency for red light? Okay, so see, first of all, you should know that Vibgyor, VIBGYOR. You know, this is the visible light. Among this, red has the highest wavelength, and violet has the least wavelength. Similarly, violet has the highest frequency and red has the least frequency. So if we consider the blue, so blue wavelength will be lesser than the wavelength of the red one. Now they have given blue, which is 5 10 to the power minus 7. So which is more than 5 10 to the power minus 7 is either C or D. Now let's come to the frequency. Now, as you know that as you go down, the frequency increases. So this has a frequency, blue has a frequency of 0.6 10 to the power 15 hertz. So red will have less than this. So 0.6 less than this is this one. So C is the correct one. Over here, C is the correct answer. I think students you must have understood this, because red has the highest wavelength and violet has the least wavelength. That means red has the highest, and as you go down, the wavelength decreases. But violet has the highest frequency and red has the lowest frequency. That means as you go up, the frequency decreases. So this point should be remembered while answering this question. Okay, 21st. Which diagram shows what happens when a ray of light passes through a prism? We all know that when it passes through a prism, it forms a spectrum. But the correct, you can refer to the diagram in the book also. You can see this is not correct, this is also not correct, this is going up, so not correct. This is the correct one. This is the perfect figure for the spectrum. You can refer it from your book also, but you should know that this is the correct one. Now, 22nd. A television TV station transmits a signal to a television receiving dish. Okay, so this is a TV station through satellite receiving dish. The television has on and off indicator light. Okay, the television is switched on by a remote control. Okay, which changes the indicator light from red to green. Okay, red and green. Yeah. Which electromagnetic waves in these actions has the longest wavelength? See, first of all, you should know what waves are these. Now, these satellites which they carry, these are the radio waves. Radio waves. This is infrared, in which the remote control operate. This is the infrared waves, and uh, you know, the red and green LED which is on TV, which is seen by us, is a visible light. Okay. Now, if you know the electromagnetic spectrum, so first of all, it comes the radio waves, then comes the microwave. You can also check electromagnetic spectrum, microwaves, then infrared, then visible light, then ultraviolet, then X-rays, and then gamma rays. Among this, you can see radio waves has the highest wavelength, and the wavelength decreases as you go towards right. Similarly, radio waves will have the lowest frequency, and the frequency decreases as you go towards right. But we are concerned only about the longest wavelength, so it's a radio wave has the longest wavelength, so A is the correct one. Okay. A sound wave has a wavelength of 0.024 meter. Okay, so wavelength is represented as lambda, which is 0.024 meter is given to us. What is the frequency of the sound waves, and is it audible to humans? Okay, we have to calculate the frequency. Now see, we can take the speed of light as 340 meter per second. Generally what this is taken. So when we know the formula, velocity is frequency into wavelength. To calculate frequency, we do velocity by lambda, that is 340 upon 0.02. So how much this will be? If I put this value in my calculator, it's coming out to be 14,166.67 hertz. You know that the frequency which is audible to human is from 20 to 20,000 hertz. So yes, this is audible frequency. So the answer of 23 is C. 24th. The diagram shows a bar magnet at rest on a smooth horizontal surface. A length of soft iron wire is held parallel to the magnet. Okay, so this is soft iron wire and this is the magnet. Now they are saying the wire is released. What happens? Now see, this is just an soft iron wire. So basically we know that an iron is attracted towards a magnet. So the answer will be B, only because the wire moved towards the magnet. Because a soft iron will be attracted to the magnet. That's why it will move towards the magnet only. Okay, 25th. A man walks across a carpet. He becomes negatively charged by friction with the carpet. What happens as he touches a metal object connected to the earth? So see, when a man is become a negatively charged, so what will happen when he touches the metal object connected to the earth? Basically, all of the negative charge that a man has will be conducted by that metal object towards the earth. So basically now man is going to lose that electrons, so there will be no charge on the man, because all the charge which is on the man, all the negative charge will flow through the wire to the earth. Okay. Now 26. A laboratory has a standard wire of known resistance. Okay, you all know what the resistance is. It also has other wires made from the same material as the standard wire, but of different length and diameters. Okay, which wire would definitely have a resistance less than the standard wire? So first of all, you should know that resistance is directly proportional to the length of the wire. That means more the length, more will be the resistance, and also resistance is inversely proportional to the area of cross section. That means the diameter should be, if the diameter is less, it will have more resistance. If the diameter is more, it will have less resistance. Now so they are saying which wire would definitely have a resistance less than of standard wire. So you know length is directly proportional, so this should be short, because they are saying less resistance. So length should be short, wire length should be short, this one, and less resistance means the area of cross section should be more, means larger, or the diameter, because area is what? Area is the diameter only, more the diameter means more area. So the area is more, the resistance will be less. So the diameter should be larger. 26th, C part is the correct answer. Okay, 27. Which diagram shows, sorry, the diagram shows a circuit. You see a circuit. Then which energy transfers occur? Okay. Now the energy transfer that is occurring is basically, you see a battery. From the battery, it is going to the lamp, because the electrical energy from the battery is going to the lamp, and when the lamp is on, it also gets heated up. So its heat is lost to the surroundings. So basically A is the correct one, battery to lamp to the surrounding air. Okay, as you can see, battery surrounding air not possible. Lamp, no. So it's basically the battery which is giving to the lamp, and from the lamp, though lamp is giving out light, but it also gets heated up, because of which the heat energy is lost to the surrounding. Okay, 28. XYZ are lamps. Okay, XYZ are lamps. In which lamp there is a current? Okay, you see, first of all, this is a DC current. Okay, it's a battery, it's a direct current, and this is the transformer. Now you should know that in a transformer, a direct current won't work, so there will be no current in X. Now this is a variable resistor, so yes, the current will flow, and you can say this as a light dependent resistor. Yeah, the current will flow. So X and Z, the current will flow. No, sorry, Y and Z, the current will flow, not from the X. So I think C is the correct option. For 28, C is the correct option. The diagram shows a circuit. See, which changes cause the bulb in a circuit to become brighter? See, this is a variable resistor, that's fine. Now see, to become a brighter means we have to, it's obvious we have to, uh, or this wire should carry more current. Okay, then only the bulb will become bright. So bulb will become bright when we increase the current. Now see, since there is a resistance, and you know resistance also causes the heating effect. So more current means more resistance and more heating effect. So that could create in an increase in temperature. Okay. So 29D is correct. Let's come to the 30th. A current in a kettle is 10 ampere and kettle is protected by a 13 ampere fuse. Okay. The owner of the kettle replaced 13 ampere fuse by 3 ampere fuse. What happens when the kettle is switched on? Now see, the fuse is of low power now. Kettle is of 10 ampere. So as the current goes above 3 ampere, what will happen? The fuse will melt. The fuse will melt, and the kettle works, sorry, and the kettle is undamaged. It's obvious that kettle is not going to work because when the fuse has been melted, so there is no current in the circuit. So basically the fuse melt and the kettle is undamaged. That's what is the fuse for, is to save your electrical appliances. But you know, this connection is not the, you can say, the correct one, because the kettle is 10 ampere and the fuse is of just only 3 ampere, so it will melt the fuse. So 30th B part is correct. 31st. Now, a wire is moved down in a direction perpendicular to the magnetic field. Okay, you see the magnetic field north south, and the wire is moved down. Three changes are suggested. First of all, the speed of the movement of wire is increased. Okay, that means now this is moving with a more down, but with a more speed. The magnetic field strength is decreased. Okay, field strength is decreased. This might be an electromagnet, and the direction of magnetic field is reversed. Okay, now the north is over here, south is over here. Okay, what changes the electromotive force induced in the wire? Okay, which changes? Increase. Okay, we are just saying increase the electromotive force. So I think increase is B, one only, because greater the speed of the movement of wire, more will be the EMF. As far as the magnetic field strength is concerned, when you are decreasing it, the EMF will also decrease. And when you are changing, when the direction of magnetic field is reversed, so that means the electromotive force direction will also be reversed. It will not increase. It will only change the direction. So 31st B is correct one. Now the next question is question number 32. Now it states that in an experiment a wire is held over a compass needle as shown. So this is a compass needle and this is wire. An electric current is switched on in the wire and the compass needle is deflected. Okay. Which rules explain why this happens and then describe what happens when the current is reversed. See, when the current is reversed. See, when the current is passing through this wire, so this wire it produces a magnetic field. So this wire only when the current is passing through the wire, so this will produce a magnetic field. Or now when the magnetic field, or because of this wire, comes in contact with the magnetic field because of this compass needle, so which causes the deflection in the compass needle, because as the two magnetic fields interact, there will be deflection. Okay, now what happens when the current is reversed? Now when the current is reversed, the magnetic field direction is also reversed, so there will be deflection in the compass needle, but now in the opposite direction. So I think C is the correct one. There is a magnetic field around the wire, yes, and the compass needle deflects in the opposite direction. Okay. 33. Over the time, the strength of the magnet in an electric motor decreases. Okay, so it's the strength of the magnet. Which row describes two ways to keep the motor running at its original speed? So at its original speed, first of all, the current in the coil, that has to be increased because the strength of the magnet has decreased, and number of turns in the coil, that has also is to be increased. So both has to be increased in order to make up the loss of strength of magnet. For that, the motor to keep in its original speed. Okay, 33D is correct. Okay, 34th. A rechargeable battery contains lithium. We know lithium. It has the atomic number of lithium is 3. The lithium exists as a positive ion. See, lithium actually, this is nucleus, and there are 3 electrons. 1, 2, 3 electrons which orbit the nucleus, and lithium loses 1 electron to form Li plus. Okay, how does the ion of lithium differ from a lithium atom? So as you can see that in lithium atom there was 3 electron, and when it is formed lithium ion, it loses 1 electron. So means the total number of electrons has decreased. So the ion has fewer electrons orbiting the nucleus. Yes, because lithium ion, which is Li plus, is formed when lithium loses electron. An iron nuclide is represented by a symbol as shown. Okay, Fe5626. Which statement about the nucleus of an iron nuclide are correct? A nucleus contains 56 neutrons. No. A nucleon number is 30. No. The proton number is 26. Now see, if an atom is given, this 56 is the nucleon number. Nucleon number is 56. 26 is the number of protons. This is also known as the atomic number. So number of electrons will also be 26. But the number of proton, you do 56 minus 26. 30 number of neutrons will be there. Now, I think only the third one. So 35th D part is correct because its the proton number is 26. Question number 36. What is the artificial source of background radiation? So see, they are saying what is an artificial source. So they are talking about the artificial source, not because there is a difference between artificial and natural source. So it's basically the X-ray machine, because these X-ray machines are produced by the humans. These are the machines which are produced by humans in hospital, and these are artificial source. Other like randon gas, cosmic rays, plant and other living, they are the natural source of background radiation. Okay, 37. A sample of a radioactive isotope has an initial rate of emission 128 counts per minute and a half-life of 4 days. Okay, so its initial is 128 counts. How long will it take for the rate of emission to fall to 32 counts per minute? Okay, see, it has a half-life of 4 days. So it will take 4 days to reach to half of its value, that is 64. Then again it will take another 4 days to reach to the half of its value, which is 32, which is the required number 4. So total it will take 4 plus 4, 8 days to reach at this point. Okay, 38. Approximately how long does it take for the moon to make one complete orbit of Earth? Now see, actually the answer for this is 1 month. The moon actually takes now 27.3 days to complete a revolution. This is 27.3 days, but you know it takes 29.5 days to change from new moon to another new moon. So it's about 29.5 days, which is around 1 month. Okay, 39. The sun has a mass of 230 kg. Okay, which element accounts for most of its mass? We know that it's hydrogen, because in sun it's basically the fusion reaction in which hydrogen is fusing to form helium, and in this process a lots of heat energy is also released, which also keeps the sun shining. Now the most which element accounts for most of the mass is basically hydrogen. Hydrogen actually accounts for 92.1% of mass of hydrogen is hydrogen, and around 7.9% is helium. Metal accounts for less than 0.1% of the sun's mass. So it's basically the hydrogen. Okay. 40th. The nearest star to the sun is Proxima Centauri at a distance of 4.2 light years. Okay. Which statement are correct? Telescope image of Proxima Centauri shows it as it was 4.2 years ago. I think this one statement is correct. One statement is correct, because if it is taking 4.2 light years, The same the telescope images also uses that light only. So whatever the image that is shown is of 4.2 years ago. If a spacecraft near Proxima Centauri sent a radio message to Earth, it would take 4.2 years to arrive. Yes, because the speed of radio wave and light is same. Proxima Centauri is outside the Milky Way galaxy. No, no, no. Milky Way is actually a very big galaxy. You know, the if you see the diameter of Milky Way is around 100,000 light years. So this is just 4.2 light years. So that Proxima Centauri is lying inside the Milky Way only. So 1 and 2. So B 40th B part is the correct one. So students, that's all for today's video. So I'll be coming with more such videos of these types of past papers. So thanks for watching and keep subscribing. Thank you.